This is a problem that I picked up that actually it's part of a quiz on using statistics in chemistry. The problem reads, a certified reference material of steel contains 2.31% of nickel. A new method is tested by analyzing this reference material 6 times. The mean value of the 6 measurements is 2.30%, and the standard deviation is 0.053%. Let alpha equal 0.05. What can we say? Solution. Let's write down what we see. The first thing we see and the first thing we always check is that all our measurements are in the same unit. They're in percentages. Percentage, percentage, and percentage. The next thing we see is that we have a population mean of mu equal to 2.31%. That's what this says. A certified reference material of steel contains 2.31%. The population is our steel, and it's 2.31% nickel. Next, we see that we have a single sample set with size n equal to 6. Then we're told that the mean value of this sample, so that's the sample mean, is 2.3. Then it says the standard deviation is 0.053%. Make sure you get your decimal points in the correct place. Now, we don't really know whether that's the standard deviation of the material or the standard deviation of the sample. So we just wrote sigma, but it could be S. And finally, we see that we have alpha equal to 0.05. So this is the data that we have from the text. What's the first thing that we look at? We see that we only have 6 pieces of data. 6 is less than 30, so we have to use the t-test. And we're assuming a normal distribution. With a single sample set, which is what we have here, this means our degree of freedom is df equal to n minus 1, so df equals 5. So we're going to be using the t-test with df equal to 5. Now, we repeat this. The null hypothesis represents the status quo. The status quo usually is the population mean. So the population mean, do we have a population mean here? Yes. The population mean was mu equal to 2.31. So that's our null hypothesis. And automatically, our alternative hypothesis is the opposite, so mu not equal to 2.31. Remember that not equals means that we can reject it from less than or greater than, so that makes it 2 tails. Okay, let's go ahead and work the problem using the t-test, as we said. That means we need to calculate the t-score. That uses the data and the critical t-value. And if the absolute value of the t-score is greater than the critical value of t, we reject the null hypothesis and accept the alternative hypothesis, usually called the sample claim. If the absolute value of the t-score is less than or equal to the critical value, we do not reject the null hypothesis. Later on, we'll discuss what rejecting or not rejecting has to do with the text in the problem. But right now, we're just working mathematically. The degree of freedom is df equal to 5 and alpha equal to 0.05. So we need to get our table. Here's our t-distribution table, and we had 2 tails, and alpha was 0.05, and we go down to 5 degrees of freedom, and we see 2.571 is our critical t-value. And that's what we have entered here. Critical t-value, Tc, is 2.571. Now we need to calculate the t-score t. We do that by subtracting the population mean from the sample mean and then dividing by the standard error of the mean. The standard error of the mean is the standard deviation divided by the square root of the sample size. So here we have our standard deviation is 0.053 and n is 6. So using a standard Windows calculator, we would first calculate the square root of 6. So 6 square root 1 over times 0.053, and we get 0.02164. That's what we've written here, 0.02164. And then put that in our memory. So 2.3 minus 2.3 0.31 equals negative 0.01. We divide that by our memory, and we get equals minus 0.4621. So this should have a minus sign here. Let's add that minus sign there. When we use it, we take the absolute value. Since the absolute value of minus 0.4621 is 0.4621, and it is less than 2.571, the critical value, we do not reject the null hypothesis. Now remember that our problem was that a certified reference material contained 2.31% of nickel, and this was a new method we were testing. And so what does we do not reject H0 mean with respect to this problem? It means that we don't reject the new method of measuring. What else can we say? We cannot say that there is no bias or systematic error. We don't know. We cannot say that the new method should be accepted. What can we say? We can say there's no indication of bias. We can and did say that the new method should not be rejected. That's this problem.